Okay, I'm recording. So here we are in no, I'm on Linux at Machon Lev, and I'm in my home directory. Oh, can you see my files? Somebody.
Yeah, we can see them.
Okay, thank you.
Yes.
Okay, so I want to write a program that mimics the shell. So, for example, I can do like this. Let's start building this. Well, I never like to build something completely from scratch, so I'll look for something that has something maybe useful. I don't know. What about, I have a program here called temp1. Let's see what that is. Cat temp1.c. Yeah, let's start with that. Very simple. So I'll do like this. I'll do copy temp1 to practice. Let's call this practice shell.c. Let's do Emacs practice shell.c. And well, the colors are not so great, but okay. So can you see that? Can you see the colors, or is it too impossible to read?
We can see the color.
Okay. So it's the light here, maybe it's not so good. Okay, so if we run this program, let's see if I do GCC practice shell.c. And now I do a dot out, and it says hello. So you see the program works. And now what I want to do is, what I want to do here, I want to do read from the standard input. Now, wait, now in order to read, I have to do man read, and it tells me that oh no, wrong manual page. So I do man 3 read. No, that's the wrong one too. Man 2 read. And I see I include UNIX standard library. So is that what I have? No. So I'm going to write uni standard. And now I can do read. And I do read from the keyboard into a buffer. So I need to make a buffer. So let's make a buffer. Not int, char buffer. And let's make it of size 1000. Okay. Char buffer 1000. And now I'm going to do buffer, comma the size. Oh. And now let's just do like this. System system, what did he read? Well, he read something to buffer. So let's give him buffer. And now I'm going to do, I'm going to do this. Yank. And now instead of hello, I'll write, I don't know, done. Okay. So let's compile our program. Doesn't like system. Oh, I didn't do man system. Man system, it's in lib. So I need to add that to my file. You understand the process that I'm going through here? And now if I do compile, and it works. And now if I run it, a dot out, and it waits here. And if I type, for example, ls, it did ls, and it wrote done. You see that? Everyone sees that. Now, so it's kind of like a shell if you think about it. Now I can do like this. I can do while one, and then I can do now I put into a loop. And instead of writing done here, I'll write prompt arrow.
Shouldn't you put that at the beginning?
What?
Shouldn't you put that at the beginning so it prints the bus number too?
I should also put at the beginning. Oh, also only at the beginning. Yeah, probably you're right. Kill and yank. And I should also probably, for good manners, take these out of the loop. And now I have my loop where I say prompt. He gets, I read something, I type it, and I run it again. So now if I run this, let's compile this. Oh, that was slow. And now if I run it, I got prompt. Oh, I got a new line. I forget. Yeah, whatever. Prompt, and I can do ls. I can do
What's with
ls pipe
the-
wc. Oh, that, yeah, that kind of worked.
I think you need to put a null after your input, maybe.
Say again. Oh, there's no null. So yeah, the read didn't put a null, right? I forgot that, but you see that. All right, so that worked. Wait, but you see that. Yeah, let's fix that. So I have to do Control C to get out of here. And now Emacs, and I go back, and I go and I say I have to say like this, I can use my variable status since I have it. Status equals, and then I can say buffer at location status equals 0. And that'll get rid of the
Why did we call it status?
what?
Why did we call this variable status?
Oh, it was just left over from the other program. No reason.
Also, you might want to remove that new line.
I might want to what?
Remove that new line.
Okay. I'll take your advice. Okay. Yeah, the variable name is pretty bad, but we're just practicing here. I don't know why I did that. Oh, I forgot to recompile it. And where's my prompt? Something happened there. I don't like that.
Is like flushing the stream a thing? You see?
Yeah, I can do F flush std out. Maybe it has to be capitalized. Std out.
Or is std out defined in one of the previous libraries?
Yeah, I hope so. Ooh, didn't like that. Undeclared. Maybe it's lowercase. Oh, I got my prompt. And I do ls and I get my thing. And I do ls pipe wc and it works. And I have like Kiilu, my own little shell here. What happens if I do cd? CD doesn't work. If I give it gibberish, doesn't. Oh, it says command
CD
not
is not
found. But,
supposed to give you any output.
oh, right. CD is not supposed to give me any output. CD slash. Okay. Now if I
Now try
do
ls.
ls, I'm still where I was. Didn't work. Because CD is not actually a command. CD is actually not, it's part of the shell, and I didn't implement it myself. There's no function called CD. There's no function called CD in there's no function called CD in the list, in the binary in bin or in
So why
sbin.
didn't it say that it was not found?
That's a good question. I don't know. Yeah, I see that. That's why I typed GFG and it told me not found. I don't know. Maybe it did run it. It did run it, I guess. It did run it. I see the shells run. Not sure. Just a second. Okay, so I don't care. It's not important to me, but I hope you see that I sort of wrote a shell here. And what other commands can we try? PWD tells me where I am. And if I do CD slash, doesn't work. PWD. But I don't care about CD for at the moment. I just want to show you, does everyone see that I sort of created a shell?
Yeah.
Well, you see, anybody else see? Anybody else there? Well, I sort of created a shell. You're there? You understand that this is kind of a shell? Or Yitzhak, you think this is a shell? Or why is it not a shell?
It doesn't have a shebang. No, sorry.
No, if it had
No.
that's no, not a shell script, a shell program. I am right now in a program. This is Nachum's program. That word prompt there is simply because I wrote it there. That prompt there is because I wrote it there. Control C. If we look at my program, I wrote prompt, print F, that says prompt there. If I would write Nachum's prompt, it would say Nachum's prompt. So I'm running this program, but it behaves like a shell because it lets me run things. Nachum shell. Prompt. Nachum prompt. If I run it. See, it says Nachum prompt. This is not the shell. I'm not in the shell, but I'm running a program of my own, which has a similar behavior to the shell. But of course, it's totally cheating. Now, why is this cheating? Because I'm using system. The system essentially asks the shell to do stuff. Emacs, yeah, the CD, you're right. The CD, it also did. It did the CD. It didn't give an error, but it didn't actually move me. Not sure exactly why. It has to do with the way the CD is written, in the shell. It didn't actually move me. It ran it, but it just didn't work. But it did succeed in running it. So let's go back to the program. Wait a second. This is what your homework 4 is going to be to do. Now, when I do this system, I'm essentially saying, Mr. Shell, please run for me whatever I got in the buffer. But I can't see that. If you're going to want to come here, you're already interrupting me. Now you make it visible. Yes, there's some open ones there. Um, okay, so this system is sort of cheating because the system uses shell. So I'm writing my own shell, but I'm using shell. So if I don't want to use this, what am I going to have to do? Well, from the commands that we saw up to now, what should I have to use? What other command did we learn? We learned exec v. We learned exec v. What parameters does exec v take? Well, it takes the path. For example, it takes, slash. Wait, somehow that slash seems wrong. No, that's right. Okay. Takes slash bin slash ls, for example. Well, let's look at our let's look at our man for exec v. What are the parameters? Man exec v. And it says exec, it tells me all of them. Exec L, exec LE, exec V. Has a path and then an array, a two-dimensional character string. Path and then a two-dimensional character string. So I got to make a two-dimensional string. So I gave it a path. I gave it a path, but I didn't give it a character string. So I got to make a character string. Well, just a second. LS minus L. So there's my character string. I have an array and I have bin LS. And now if I go over here, and I type array, and I compile it, GCC, and I do it gives me Nachum prompt, and I type in ls, and it runs ls. Well, the problem is I type pwd. Oh, well, wait a second. What happened? Why doesn't it say Nachum prompt? I do ls, I do ls, and it ran ls, but now it didn't even Nachum prompt. Anyone know what the problem is? Hello? Anyone out there?
I would answer, but I don't know.
the answer.
So the answer is that exec, that's why I just explained to you today in class, that exec v replaces the process with whatever process I gave it. I gave it ls here, So now ls is running. It never goes back to the loop because this process is finished. In other words, I replace this my program with ls. So it runs the first time, but the second time, it's finished. Once ls is finished, the whole program finished.
So you would need a fork before?
So I need to delegate this job to a child. So let's do that. Let's do like this. If, are you guys following me?
For the most part.
Well, if you're not following something, now's the time to tell me what you're not following. You want to stop me. You're allowed to say, I don't understand why you did that. You're allowed to say, what are you doing now? You're allowed to say anything.
It's because exec v just kind of stops everything, right? It's its own program.
What execv does is it says, instead of running the program that's been running up till now, run the process that I write over here. So it's instead. So instead means instead. So it doesn't continue the loop because it's no longer in the loop. But now if I say, if it's the fork, if it's the child, then run this. So now let's run it. And now if I do ls, it ran. If I do ls, oh, the prompt, what happened? I don't see the prompt. Why don't I see the prompt? Anybody know?
You see it when you type something afterwards, no?
No, here, look. Prompt, it came out over here. Ah, yeah, you see, you're right. You do see it there. You're right. You do kind of see it. So what's the problem? It's not printing at the right time, right? So how can we fix that? Well, how can we
Be a
fix that?
wait, like a parent
Exactly.
Is
and
that
a
a
wait.
delay?
With a wait, right? What we have to do is, if it's the child, this is a review of everything we did just now. If it's the child, run the thing. But if it's not, else,
Do you need you don't need an else, do you? Because
you're right. You probably don't need an else. You're right. But I'll do an else anyway, just for courtesy. If it's the parent, then do await. Now I'm being a little bit ugly here because I'm using the same variable for different things. But if you think about it, it's totally fine because when I use status over here, I immediately used it and I'm finished with it. I don't care if anybody uses it again now. It's outlived its usefulness. On the next loop, I'll use it again, but on this loop, it's outlived. Now I can use it for this wait status. So this wait, essentially the father is waiting, not going to continue the loop and print this until this child finishes. So let's see if that helps. Ooh, wait, I didn't do a man on wait. Let's do man wait. Sometimes you say that to somebody, man, wait. But it's in the wrong section. I got to do two. There's different weights, you see. I got to do a two includes system weight and system types. Probably don't have to do system types, but I'll do it anyway. Q. So let's do sys slash types. What's going on? Why not letting me do what I want to do? Now let me do it. Types dot h wait dot h. Looks good. Oh, success. See, you want to clean, you don't want to see anything. Now, if I do out, Nachum prompt, I do ls, and I get Nachum prompt at the right time. You see that? Because it waited for the child to finish executing this little ls before printing the Nachum prompt.
Why is it doing it in like the -A format?
-L really, but also maybe
Yeah,
A.
that -A. -L. Yeah.
Why is it doing it wrong? Because look, I'll show you something really weird. When I do PWD, it also does ls. When I do gibberish, it also does ls. No matter what I type, it's just doing that. Anybody tell me why?
Because that's what you hard coded into exec.
Because that's what I hard coded into it. I just made a fake, totally fake shell because I didn't deal with the problem of what command to run because I wanted to leave that for later. First, I wanted to show you the problem of the prompt and of waiting for the prompt and how that uses a fork and how I had to use a fork and how, first I want to show you that the loop works. Then I wanted to show you, the loop won't work unless you do a fork. Now I want to show you that I need to wait in order for the prompt to come out right. Now we have only one more problem, which is, well, we have a couple of problems, which is how to execute the command that he gave us. Because let's do Control C. See, I'm building it up slowly. I'm building up the program slowly and just making sure that along the way, the parts that I want, of course, I've done this program before. You would not necessarily know which parts are easier to work on and which parts are later. I'm saving the hard part for the end. But I've kind of got a shell going here in very few lines. But the main thing that the shell does is not just to run exec and do wait. He also has to find where this, I wrote just bin ls. Now, where is that? How am I supposed to know that? I can't hard code that in. So let's go like this. There's a function called getEnv, get environment. Which environment variable do we want to get? Well, we want to know the path of this user because that's where we're going to look for the command that he gave us in his path, not in any path, in his path. So there's a function called getEnv path, and I believe you write something like this. Let's check how the getEnv function works. Man get env, because I forget. Well, it's in the standard lib. That's good. We already included that. It just takes that single character, that single path, but it returns me the path that I want. That's the path. So let's do Q. First of all, you're finding this useful, students?
Assume it's useful for the homeworks.
It's certainly useful for the homework, but yeah. I mean, useful in the sense, is it like in explaining some of the things that we did already today?
Yeah, it's nice to see it in action, actually.
Okay, good. I need positive encouragement, otherwise I feel like I'm wasting my time. Okay, so we have this buffer that we're going to use. That's the command that he gave us, but we need the path. So we need another buffer. So let's go like this. Yank, yank, and let's call this, instead of calling it buffer, which is a really bad name, let's call it path, since it is the path. I don't know why that spaced out like that. Okay. Oh, it's because it probably should be spaced out. Probably. Whatever. Okay. So get end wants to return me into a path. Where get end? Here we go. Path. Now, can I do that? Will that work? Maybe. Path is now pointing to whatever get and returned. You might want to do a copy. I would rather do a copy. I'm worried about that. I'm always worried about pointers and, you know, what he's returning to me. It's a pointer to something where, oh, actually it's an invariable. Should work. So actually I don't need to do what I did here. Let's change this from path to being a character. Let's just do a pointer. Let's see if that works. That should work because it's an environment variable. It's already a variable. It's already, let's think about it logically. It's called an environment variable. I mean, it's already a variable. It already exists. It's out there. So it's already out there. So I should be, so I can just point to it. Should work. And now let's just see if we got it. Before we change anything else, let's do print F. What do I got to write now? What's it should I write in here? I want to print the path. What do I got to write over here so I can print a path? What type of thing is it? Not a decimal number. What is it? String. It's a string. Just like we figured out. So I do S. I might want a new line. And let's get rid of this exec because is that an FB or an FB? And let's
Comment this out.
we don't want this execution at all at the moment. So let's run our program now. Now we should be getting the path. Ooh. I spelt it wrong. Gent. I wrote Gent. See how smart it is? It says, did you mean get? Uh-oh, I have a dry cough. I'm gonna die from corona, I think. If I'm dead in a month, just tell everybody that I figured it out.
Do we get 100 then?
No, then you're screwed. I don't know. Then you're totally screwed.
Has it ever died in the middle of like the semester?
I think it did happen. I don't know. I don't know. Sure, it must have happened. Not that I don't know of a case. I don't know what, if I do. I might know of a case, but I don't know what I did. Here, get env. I type something, and it gives me the path. Yippee! Now look at the path now. It's this. What am I going to do with this path? I don't want all of these places. I want just the right one. I want bin. I just want bin. So in order to do that, in order to get the right one, I have to cut it up. So we learned about, I think we learned about string toke. Do you remember that?
Vaguely.
So there's a command called strtok, and I can give it path, and what I want to divide by. I want to divide by a colon. And it will return to me a token. So let's call it, it's also a bad name, char star token. Because you really should say what token it is. It's a path element. This should be called full path, and this should be called path. So let's change it. Since names are important, let's call this full path, and let's call this path. Well, that can be also confusing, but because they're so similar. And let's change this to full path, and this call full path, and this we'll call string toke full path, but it's going to give us path. And we'll still print path, which is the local one that we got. Let's run that. Ooh, string toke. Ooh, string toke with a Q. I thought there's a function called strtok. Oh, I didn't include string.h.
Why didn't it throw an error if you forgot to include?
It did throw an error. That's an error. What do you mean? It doesn't know that I didn't. How does it know that I should have included? If it knows that I should have included, then why should I ever bother including anything? Let it just include it itself. If it knew that I should have included that, I can't logically, it shouldn't know that I didn't include that. That's the whole point of telling it what I want to include. It doesn't know. So no. Uh-oh. Internet connection is not good.
You still there?
I'm still here. I'm waiting, but my computer is not here. It sort of hang. I think I lost my connection to Machon Lev. Okay, so let's try that again. And I got in, I think, and I wrote already string.h. So let's try compiling it. GCC practice shell, enter, and it compiles nicely. So now I go a prompt and I type something and it tells me that, look at that. Everyone sees? It gave me the first, and if I do another ls, it still gives me, just keeps giving me the same one. User local. Now, if I do control, see, if I do echo dollar path, I'll see that that is indeed the first one. User local bin is the first one. But I want to get the second one. I want to try them all. I want to search for it. So how do you do that? So you have to make a loop, obviously. See how I'm slowly building up this program? Getting, you could never just start writing this program and do it all right from the beginning. Now I need a loop to get through all the paths. So that's the full path. So I need to do a loop here. Now the first time I'm gonna call it like this. I'm gonna do I'll do that only once. I'll do that only once. But now here is a loop. Now, of course, it could give me null right away. It could be the path is empty. So I'm gonna say like this. If if path, then while, no, if path, then brace, I'll do like this, print the path. Close the if. If there is a path, then print it. After I print it, I want to do another path. So I'll do a while. And I'll do like this, while path equals str toke, string toke of the full path, comma, null. When I give it null, what? Oh no, I did that wrong. Sorry, I do it like this. I think I do it null, comma, and then the delimiter again. And that says that since I didn't give it a path, the path, I didn't give it a thing to a string to tokenize, to cut up into sections. I give it null, it knows to use the previous one. You can do this in C++. You remember how to do this in C++? How to write a function that works like that? You remember your C++? You remember static variables?
Sure.
That's a static variable. That is the classic use of a static variable. Where if it's undefined, then use what it was already defined as. Okay, that's a static variable as opposed to a static member of a class, which is something else. Remember, independently, there's such a thing as a static variable. I don't know if you learned that. Anyway, path equals the string at place 0. In other words, the new path, if that thing does not, if that thing exists, actually, I don't need a double parenthesis. If that thing, I don't know, I can use whatever. If that thing exists, it's kind of funny to do like that. Wait, so if I got a new path, then print that one too. Okay, it's a little bit messy. Can we fix it up? Okay, that's a little bit better. This one doesn't look so good though. Oh, all right, whatever. So now we're saying like this. First, get the path the first time. Give it the full path that I got. Then, if the path was really a real path, then print it. And then start a loop where you go through getting all the paths, assuming that you get one. That's why I had to boo it. That's why I had to check for in a while loop. Okay. So now let's recompile it. And look at that. No errors in syntax. So let's write anything. And look at that. You see that? We got all of our paths. And one of them, fortunately, is bin. One of them is bin. And that's the one we want. But how are we going to know that? We're not going to be able to know that. Any suggestions? So it's like this. I got a path. This is my first path. Let's take that first path. Now let's do like this. We need another variable. So we need, let's make another variable called like, you know, char command, the command that we're going to run, command to run. Okay, so we made our command to run. And we're going to try to create that command. Instead of it just being hard-coded bin ls, we're going to start the process of doing that. Now we're going to use a function called strcat. Anyone remember that function? String concatenate. You concatenate the strings with that function. You combine them. So if I give it, for example, the path that I got, and I give it quote slash ls quote. So path should now be a new thing. It should have been expended. Let's see if I did that right. How can we check if I did it right? Well, we can go like this. And print it. After I got the path, then I concatenate the ls to it and I print it. Now, I'm going to want to do this also for the other paths that I get. So let's put it
There's no some type of debugger for stuff like this.
What debugger? Who needs a debugger? What do I need to debug?
I don't know.
Yeah, there is. It's something called, I think it's called Godzilla, right? There's an Emacs debugger, but who needs a debugger? Just
Print
just
everything out.
just print everything out. But it's easy. It's better to print things out because the debugger, it's right. You can look at it, but yeah, you're right. You said it's a little bit tedious. Is that what you're saying? Think it would go faster another way?
If you're not used to coding in command line, then like
Okay, now I do like ls, and oh, that doesn't look good.
infinite loop or something.
I think maybe I did the wrong thing with the concatenate. Man, strcat. Yeah, no, I did it right. I must have done something else wrong. Let's see. Now I need a debugger. See, you shouldn't have said that. Now I need a debugger. So let's comment out my string concat. And just print it. I think it worked. Didn't we do that before? Let's just make sure that works.
Everything's a haze.
Yeah. So that worked. So what's wrong with my string cat? Isn't it hard for you to read the red? I find it very hard.
Everything's just hard to read. I like the purple and the green.
Yeah, you can read it. I like everything just to be white.
Well, I'm colorblind. I'm joking. I don't see color.
You don't see color. You're woke. You don't see color.
I'm woke.
ls. Problem is that path is just a pointer, and I can't really copy stuff to it. It has no space. It doesn't have the right amount of space. So what I'm gonna do, you see, that was the thing. This path worked very nicely for a little bit, but now it doesn't work. So what I'm gonna do is I'm gonna say that path is a pointer. Then I'm going to do like this. Path equals, oh, well, that's not gonna help. Ah, yeah, I'm gonna do like this. I'm gonna go back to the way I did it before, then it should work. Still technically not perfect because I'm hard coding in these sizes. Technically, you shouldn't do it like that. You should check the length of it and make everything the right length. You see what I mean? And then here is not going to be this. It's going to be comma strcpy. But actually copy the thing that he gave me into path, because path is a real thing now. It's not just a pointer. And now this concatenation will have space to do the concatenation. That should improve everything. Yeah, I forgot to fix the other one. See, the compiler helps you. I changed one to a string copy, but not the other to a string copy. Hmm. Anyone see the magic that I'm doing over here?
It's been all magic to me the whole time.
Wait, do I have the right number here?
Let me look at my dad's mailing list.
No, do you see that what I did there? I did while string length of whatever string copy copies. It is while string length, as long as string length is not going to return me 0, which it will do when the length of it is 0. So when when string copy will also return me the string that it copied.
Oh, this. Wait, give me a second.
Anyway, that little magic should work. No, Mr. GCC. Thank you. You have to think about that. You got confused there. Now I type some gibberish. Look at that. Lo and behold, see what I got? User bin ls. See, I got the ls appended to it. Are you with me, Daniel? Are you Abraham, you with me?
I'm being distracted by
By your computer.
well, no. Well, if you call my fiance computer, then yes, I'm being distracted by
I don't know. I don't think you're being distracted by your fiance. I think you'd be distracted by your computer.
now being distracted by her. She's asking me questions about our mailing list for our wedding.
Uh-huh.
Leave me alone. I'm playing or learning Unix.
Yeah, you're becoming a eunuch. Anyway, all right, let's just do the last little bit here before we have to break. And that is that I got now the proper string, so I can replace my exec with my little old path that I got. You see, this bin ls is no longer necessary. I can just type path. And that will work if it's the first place, but it might not be in the first place. So I'm gonna have to cut and paste this code, this one line, to inside the loop when I go through all the path places. And these printings are not necessary, but we'll do them anyway. And let's see what's going to happen. Notice what I did here. I did many exec v's. Now, what's going to happen is that if it fails, if it's in the wrong path, it's going to fail. And then it won't end. It won't replace my process. But the minute it finds the right location, it will replace the process and run that location. So in the minute I get success, it'll stop the loop. If it doesn't get anywhere success, it'll end anyway. Now, if I do a out and I type in gibberish, oh, look at that. It ran ls. It found it. But notice that it didn't find it right away. Look. Wait a second. I ran my gibberish. It looked in user local sbin ls, didn't work. User local bin ls didn't work. User s bin ls until it eventually found it in bin ls. Then it ran, and it ran. It printed out all the LSs, and then it didn't print anything more. It didn't continue trying, and that's because the the minute the exec v succeeded, it replaced the process and ran the ls command, and therefore it never had a process to come back to, and it couldn't try the other ones. But that's great. We don't want it to keep trying once it succeeds. So it'll keep, but if it fails, so wait, let's just add one more quick thing, simple thing. Oh, where are we going to put the fail message? So when does it fail? It fails if it does this whole while loop and never succeeds in execing and finding it. Also, if the path is non-existent. So it will fail if it gets here. Oh, not there. If it gets here. So let's do print f. Nahum says command not found. I just say it like that because we might want to put a new line. So let's go back. \n. Now let's change our command from whatever it was, ls, to being something that doesn't exist, like, you know, here, let's put it here. If I put gibberish, now when I try to compile it, now look what's going to happen. If I run it and I type anything, it's going to try all the places looking for ls. The first one I didn't change. But the other ones I changed, it's not going to find it, and it's going to write, hey, how come I didn't write command not found? I put the if in the wrong place. So you got to test for everything. You got to test. Well, what if it doesn't work? Will it print? Will it print the error message in the right place? And it didn't. So why didn't it print? I put it in the wrong place. This is on the if. Oh, if the fork. Oh, wait. If it is a fork, then I'm the child, and then I want to get the path and do all this stuff. And if I get all the way to the end, I did my while loops and I finished. Well, why shouldn't this be the right place? Or maybe I have to do a flush. I don't see why, but well, std out.
Should you just put a pin in it for this week and try just finish it next week?
We're not going to finish it next week, but
Oh. Could you
let me just
could you just post the solution is, because I have to run now and classes are officially
okay.
over.
You can go. You can go. Everyone can go. I'm just going to finish this for the sake of the video, and you can go.
You'll just finish it off screen and continue recording?
Yes, you guys can leave.
All right, thank you.
Sure.
Have a good week. Shabbat shalom.
Shalom. print F. No, I can try moving it anyway, even though I don't see why. Maybe I have to think, maybe I made a logical mistake, maybe it has to be there. Let's see. No, all right, so we'll finish that next time. I don't know why that didn't print, something I did wrong, but the point is, I did a lot. I got it to print the command, and to run it, if it was correct, it would have succeeded in running it. All right, we'll stop there. Stop